Unit 2B, Lesson 4. Two standards to cover in this lesson. The first one, prove the law of sines and cosines and use them to solve problems. The second one, understand and apply the law of sines and law of cosines to find unknown measurements in right and non-right triangles. Previously, we've used the 6 trig ratios as well as the Pythagorean theorem to help us solve right triangles. The law of sines and law of cosines, those are going to allow us to solve any triangle, whether it's obtuse, right, or acute. First, we'll discuss the law of sines. If we have any basic triangle ABC with side lengths little a, little b, and little c, we have this proportion that we can create. The sine of angle A over side A is going to be equal to the sine of angle B over side B, which would be equal to the sine of C over side C. We could also take the reciprocal of this top one to get the second equation. This one's going to be useful if we're looking for a side length. This one's going to be useful if we're looking for an angle. This is the law of sines. Now we need to go through a proof for where the law of sines comes from. First, we're going to focus on the left side. We have the triangle ABC with an altitude drawn in from vertex A perpendicular to side BC. There's a couple of different equations we can write. First, we know that the sine of angle B is equal to h over c, and we also know that the sine of angle C is equal to h over b. We could isolate both these equations to get h by itself. On this left one, all we have to do is multiply by c to both sides. So if we do that, we're going to have c times the sine of b equal to h. If we do that on the right side, multiply by b, we're going to have b times the sine of c is equal to h. Looking at these equations, since both of them are equal to h, we can set both of these expressions equal to each other. So c times the sine of b must be equal to b times the sine of c. Now we need to be a little creative. I'm going to divide both sides of the equation by the sine of b, and I'm going to divide both sides of the equation by the sine of c. And if we do that, we're going to get c divided by the sine of c equal to b divided by the sine of b. You can start to see that we are getting part of the law of sines already. Now we need to use the triangle that's on the right, go through a similar process to come up with the rest. Difference in this triangle is that the altitude is drawn from vertex B this time. I know that the sine of angle A is equal to h over c, and the sine of angle C is equal to h over a. Again, if we isolate h by itself in both these equations, we're going to get c times the sine of a is equal to h, and a times the sine of c is equal to h. Since both those expressions are equal to h, we can set them equal to each other. We get c times the sine of a is equal to a times the sine of c. Now I'm going to divide both sides of the equation by the sine of a and divide both sides by the sine of c. If we do that, c divided by the sine of c is equal to side a divided by the sine of angle a. All we have to do now, the last step, is combine both of these parts. Since b divided by the sine of b is equal to c divided by the sine of c, and a divided by the sine of a is also equal to c divided by the sine of c, we can combine these equations into one. Thus we get A divided by the sine of angle A is equal to B divided by the sine of angle B, which is also equal to C divided by the sine of angle C. This is the proof for where the law of sines comes from. Next, we need to discuss the law of cosines. The law of cosines allows you to find either an angle or a side length as well. All right, so there's three different forms for the law of cosines. The first one, a squared is equal to b squared plus c squared minus 2bc times the cosine of a. Or we can have b squared is equal to a squared plus c squared minus 2ac times the cosine of angle b. And the third one, c squared is equal to a squared plus b squared minus 2ab times the cosine of c. Some things to recognize: the side length we have isolated by itself is going to be the angle we're using. So if this is side C, this is going to be the cosine of angle C. And whichever side we have isolated by itself, the other two sides are the ones we're squaring and adding together and then multiplying when we subtract. Okay, so just recognizing this pattern. We could go through the proof of the law of cosines. It's a little more complicated than the law of sines in my opinion, so that's going to be something we do together in class. To end this lesson, we are going to go through a couple of examples applying the law of sines and the law of cosines. In this first example, we have triangle XWV. In this triangle, we know two of the angles and one of the side lengths. So we have to find the missing angle and the missing side lengths. In this case, we know two of the angles. It's going to be easiest in that case to find that other angle right away because we know all three angles add up to 180 degrees. 180 minus 140 is 40 degrees. 40 degrees minus 13 degrees is 27 degrees. Right away we know the measure of angle X is going to be 27 degrees. Now technically we could use the law of cosines or the law of sines to solve the rest of the side lengths, but in this case it's going to be easiest to use the law of sines. So in this triangle, that's what we're going to use. Let's solve for length W first. W over the sine, angle W we know is 13 degrees, so the sine of 13 degrees must be equal to 19 over the sine of 140 degrees. To get W isolated by itself, all we need to do is multiply both sides of the equation by the sine of 13 degrees. Thus, W will be equal to 19 times the sine of 13 degrees divided by the sine of 140 degrees. This is something you are going to type into your calculators to get an approximation, and if you do that, you will get W is approximately 6.65. Now the only thing we have left to do is to solve for side length X. We can set up a similar proportion. We're looking for X, that's going to go in the numerator, divided by the sine of 27 degrees must be equal to 19 divided by the sine of 140 degrees. To get X isolated by itself, multiply both sides of the equation by the sine of 27 degrees, which will leave us with X is equal to 19 times the sine of 27 degrees divided by 140 degrees. Again, type this in on your calculators to get an approximation. And if you do that, you will get X is approximately 13.42. Now we found the missing angle and the two missing side lengths. One way to check to see if our answers are reasonable is the shortest side will always be opposite of the smallest angle, and the longest side will always be opposite the longest angle. So if we look, our smallest angle is 13 degrees, which means side length W should be the shortest side. So we have 19, X was 13.42, W was 6.65, so W is the shortest side, so that checks out. Our largest angle is V, which means the longest side should be 19, which it is. So that's just a quick way to check and see if your answers are even reasonable. The smallest angle is opposite of the shortest side. The largest angle is going to be opposite of the longest side. In this next example, we have triangle UST. In this triangle, we know 2 of the angles and 1 of the side lengths. Since we only know 1 side length, we cannot use the law of cosines. In order to use the law of cosines, we have to have at least 2 of the side lengths. So before we can use that, we have to use the law of sines again in order to find one of those missing side lengths. First, since we know 2 of the angles, we can find the missing angle, which means the measure of angle U is going to be equal to 127 plus 23 is 150. 180 minus 150 is 30 degrees for the measure of angle U. Now we can go through and solve for, let's just say, side S. So if we're looking for S, that is opposite of angle 127. So S divided by the sine of 127 will be equal to 10 divided by the sine of angle U we found is 30 degrees. To get S isolated by itself, we have to multiply both sides by the sine of 127. If we do that, we get S is equal to 10 times the sine of 127 divided by the sine of 30 degrees. Now if you plug that in on your calculator to get an approximation, we get S is approximately 15.97. Now we know 2 of the side lengths. Now we're going to apply the law of cosine to find the missing side length. We're trying to solve for side T using the law of cosines. T squared will be equal to 10 squared plus S we found is 15.97 squared minus 2 times 10 times 15.97 times the cosine of the angle opposite of T, which is 23 degrees. Now the easiest thing to do is just use your calculator and simplify this right side of the equation. And if you do that, you get T squared is going to be equal to approximately 61.03. To get T isolated by itself, take the square root of each side. We get T is approximately 7.81. When using the law of cosines punching this in, make sure you use parentheses where appropriate. Alright, now we have both side lengths and the missing angle found. Again, we can check. S is supposed to be our longest side, which 15.97 is our longest side because that has to be opposite of the largest angle. 23 degrees was the smallest angle, so it has to be opposite of the shortest side. So T has to be the shortest side, which it is. Just a quick way to check and make sure the answer is reasonable. In this example, we first had to use the law of sines. Once we had 2 of the side lengths, then we could apply the law of cosines. This last example we're not going to solve. We have triangle TUV with all 3 side lengths. You need to determine how we could solve this triangle. We either have to use the law of sines or the law of cosines. The Pythagorean theorem is not going to help because first, we don't have a right triangle, and secondly, we already have all 3 side lengths. So in order to solve this, we have to find all 3 angles. You need to problem solve and determine how we can do that using either the law of sines or the law of cosines or a combination of both. All right. We are going to have a discussion at the beginning of class about how we could approach this, so make sure you're prepared for that. If you think you can solve this, go ahead and attempt it.